Hello, this is Yami here. I'm going to solve question 2 of homework 5. So we have f of xy equals to 1 upon ay square x, and we have just 4 questions which we are going to solve. So first question is, draw the non-zero definition region of f of xy. So we have f of xy equals to 1 upon ay square x, where y is greater than equals to 1 upon y is less than x less than y. So this is y, this is x, and this is our region. X equals to 1 upon y, this is x equals to y, this is 1. Now second question is, we have to find a so that f of xy is a valid joint density function. We have f of xy equals to this. So integration of 1 to infinity, integration of 1 upon y to y, 1 upon ay square x dx dy, which is equals to integration 1 to infinity 1 upon ay square integration 1 upon y to y, 1 upon x dx dy, which is equals to integration 1 to infinity 1 upon ay square ln x from 1 upon y to y, which is equals to integration 1 to infinity dy, 1 to infinity 1 upon ay square ln y minus ln 1 upon y dy, which is equals to 2 by a integration 1 upon infinity ln y upon y square dy. We are supposing ln y equals to w and y equals to e raised to w. So we have 2 by a integration of 1 to infinity ln y upon y square dy is equals to 2 by a integration 0 to infinity w e raised to 2w dew, which is equals to 2 by a integration of 0 to infinity w upon e raised to 2w e raised to w dw, which is equals to 2 by a integration 0 to infinity w e raised to minus w dw, which is equals to 2 by minus 2 by a w e raised to minus w 0 to infinity minus integration 0 to infinity e raised to minus w dw, which is equals to 1. Therefore a equals to 2. And we have third and fourth question, that we have to find we have to show that fx and fy are valid density function and draw the marginal density of them. So integration minus infinity to infinity f of x comma y dx equals to integration 1 upon y to y 1 upon y square x dx equals to ln y upon y square, where this one y is between 1 and infinity and is 0 otherwise. So we have the graph as follows: f of y we have f of y is integration 1 to infinity ln y upon y square dy, which is equals to 1. Therefore f of y is valid probability density function. And for f of x we have minus infinity to infinity f of xy dy which is f of x equals to integration 1 to x to infinity 1 upon 2y square x dy, which is equals to 1 upon 2 when x is between 0 and 1, and integration x to infinity 1 upon 2y square x dy, which is equals to 1 upon 2x square when x is between 1 to infinity. So we have f of x as this. This is how we solve question 2.